right. Nah, not until nothing until the last week before the break. So the Tuesday before, you'll take the quiz on 5-4 and 5-5. So that's a week from Tuesday, so like the 22nd. So next Tuesday is the 15th. We're gonna work this week on 5-4. Next week we'll do 5-5, where you get more messages of hate. No, the following week. It could be. It's 3 days, so and you got to come in for one of them, and that's the day we'll take the quiz.
In school?
Yeah.
What?
Yeah, in school.
Uh-oh.
Oh, that's a problem, is it?
The little pit.
Is that gonna be a problem for you, there, buddy?
Maybe a little one.
All right, so sum and difference formulas. We'll start with the sum formulas. The sine of u plus v equals sine u cosine v plus cosine u sine v. The sine of u minus v equals sine u cosine v minus cosine u sine v. I will tell you this, even though it's in school, you will be able to access anything you want that somebody at home would be able to access. Like a phone, a book, anything you want, because it wouldn't be fair for kids who are virtual if you got to take it in here. So you'll have access to anything you want. All right, and this part you can write down if you want to. All right, it's completely up to you. These are just little things in terms of doing them. When finding the sine of the sum and difference of two angles, you multiply the sine of one by the cosine of the other. The sine SIGN between the two is always the same as the sine of the original problem. And basically what you're going to do is you're going to take the angle and divide it into two angles that are either in the pi over 3 family, pi over 4 family, or pi over 6 family, and go from there. All right. Good. Cosine of u plus v. When finding the cosine of the sum of the difference of two angles, you multiply the cosines of the two angles and the sines of the two angles together. The sine between the two is always the opposite of the sine of the original problem. So the cosine of u plus v is cosine u cosine v minus sine u sine v. Cosine of u minus v is the cosine u cosine v. Again, you will have these formulas at your disposal. You just have to be able to utilize them. All right, and then the two trickiest to do because they're complex rational expressions. Tangent of u plus v equals tangent u plus tangent v over 1 minus tangent u tangent v. Tangent of u minus v is tangent u minus tangent v over 1 plus tangent u tangent v. The sign of the numerator is the same as the original problem. The sign of the denominator is the opposite. Good? All right, let's go through some samples for you, and then you're good to go. Okay. So, find the exact values of the following. Cosine of, oops, add on. Unfreeze this. So you can see what I'm talking about. Find the exact values of the following. Cosine of 75. Now, you have choices, you'll still end up with the same answer. For example, 75 is 45 plus 30. All right. You also could have 120 minus 45. You could have many different answers. You'll end up with the same answer. All right. So when you do these and you'll get an assignment, all I would expect you to do, this is your choice, is 75 is cosine of 45 plus 30. All right. 45 plus 30. Then all you do is you look at the notes you just wrote down and you go, okay, the cosine plus. Cosine plus says multiply their cosines together. That'd be cosine 45, cosine 30. All right. And then it says to do the opposite. So minus sine 45, sine 30. That is the only thing I need to see in terms of work. All right, that's the only thing I need to see in terms of work. Whether it's in the homework, whether it's in the quiz you take on this, whatever it is. All right. Then the cosine of 45 is root 2 over 2. The cosine of 30 is root 3 over 2. Minus the sine of 45 is also root 2 over 2. And the sine of 30 is 1/2. Root 2 times root 3 is root 6 over 4. Root 2 times 1 is root 2 over 4. And since they have a common denominator, I end up with root 6 minus root 2 over 4. Okay. If you can get right from there to there, I'm fine. Now, just so you know, and you don't necessarily have to write this down, it could also be written 120 minus 45. And then it would be cosine 120 cosine 45 plus sine of 120 sine of 45. The cosine of 120 is negative 1/2. Cosine of 45 is root 2 over 2. The sine of 120 is root 3 over 2. The sine of 45 is root 2 over 2. And then I'm going to have negative root 2 over 4 plus root 6 over 4, which is negative root 2 plus root 6 over 4. Those answers are the same. So it's up to you. Ladies and gentlemen, with all of these, and I do mean all of these, you're going to end up with a root 2, a root 6, and a 4. Every single one of your answers in these has a root 2, a root 6, and a 4. It's just in a different order and different positives and negatives. Now, on the back, sine of pi over 12. If they give it to you in terms of radians, I would suggest that you turn it into degrees. Remember, pi from earlier in the year is considered 180 degrees. 180 divided by 12 is 15. All right. Then again, you look at your formulas and you go, okay, 15 would be sine of 45 minus 30. All right. So that would be the sine of 45, cosine of 30, minus the cosine of 45, sine of 30. The sine of 45 is root 2 over 2. The cosine of 30 is root 3 over 2. All right. Minus the cosine of 45 is root 2 over 2. Sine of 30 is 1/2. Root 2 times root 3 is root 6 over 4. Minus root 2 over 4. And you end up once again with root 6 minus root 2 over 4. All right. Good. All right. A couple more tangents. Tangent of 75. 75 is 45 plus 30. So this becomes the tangent of 45 plus 30. All right. So with tangent, the numerator is the same sign as the original problem. So tangent of 45 plus tangent 30 all over 1, and then the opposite sign, the product of the two different degrees. All right. Now, the tangent of 45 is 1. The tangent of 30 is root 3 over 3 over 1 minus 1 times root 3 over 3. Anytime I multiply by 1, I get that. All right, so those come from the tangents. Now, this is where you got to be able to work with rational expressions. The denominator here is 3, so the denominator of that also has to be 3. So I got 3 over 3 plus root 3 over 3, 3 over 3 minus root 3 over 3. What I then can do is put these together, all right, and that'll give me the expression 3 plus root 3 over 3 over 3 minus root 3 over 3. If you don't recall this from the glorious days of Algebra 2, when you have the same denominators in a rational expression, guess what they're going to do to each other? Cancel out. You just cross them out. That leaves me with 3 plus root 3 over 3 minus root 3. Now I got to rationalize the denominator. To rationalize the denominator, I multiply by the conjugate. The conjugate is going to be 3 plus root 3 over 3 plus root 3. All right. When I do, I FOIL or distribute. 3 times 3 is 9. 3 times root 3 is plus 3 root 3. 3 times root 3 is also 3 root 3. Root 3 times root 3 is root 9 plus another 3. All over. When I do the same thing on the bottom, 3 times 3 is 9. And in case you don't recall, that and that will always cancel when you do it. And I end up with minus 3. Now I collect like terms. 9 plus 3 is 12. 3 plus 3 is 6. I got 12 plus 6 root 3 over 6. And then the last thing you check is, does that go into those? Which it does. So my final answer would be 2 plus root 3. With the tangents, guess what? It's always going to be 2 and a root 3. All right. If you have tangent of pi over 12, again, that's 15, which would be 45 minus 30. So the only difference is we're doing tangent of 45 minus tangent 30 over 1 plus tangent 45, tangent 30. So whatever the operation is here, that's the operation there. Whatever the operation here, it's the opposite here, and this is always the product. Tangent of 45 is 1. Tangent of 30 is root 3 over 3 over 1 plus root 3 over 3. You'll notice they're pretty much the same thing. This will eventually become 3 minus root 3 over 3 plus root 3. So if you want to show all these steps, feel free. If you want to go right from there to there, I'm fine. And then when you multiply by the conjugate, this time it's going to be 3 minus root 3, 3 minus root 3. This is going to be 12 minus 6 root 3 over 6, which would be 2 minus root 3. So again, the 2 and the root 3 will always show up. The difference is which one comes first, the minus and the plus and all that good stuff. All right. Good. All right. The last thing then is when they give you values rather than degree measures. So given, find sine of u plus b, given the following: sine u equals 4/5, 0 is less than u is less than pi over 2. Cosine v equals net, that should be a v, by the way, you gotta make that one correction on yours. Cosine v is negative 12 over 13. V is between pi over 2 and pi. Now, you don't have to graph if you don't want to. It's not mandatory. All right? But this is the idea. They tell you that sine is in the first quadrant, so that's there. Sine's 4 over 5. You can then use Pythagorean theorem or triple to get that side. They tell you cosine v is negative 12 over 13, and it's in the second quadrant. All right? What you then are able to do is figure out what the others are. So in other words, this one comes out to be 3, so the cosine of u is 3 over 5. This one comes out to be 5, so the sine of v is 5 over 13. If you can do that without drawing it out, feel free. All right. And then from there, it's exactly what you did before. So the sine of u plus v is sine u cosine v plus cosine u sine v. The sine of u is 4 over 5. The cosine of v is negative 12 over 13. Plus the cosine u times sine v. Cosine u was 5 over 13 we found. And the sine of v is 3/5. So one of them they're going to give you. You use that to get the other one. Now we multiply. 4 times negative 12 is negative 48. 5 times 13 is 65. 5 times 3 is 15. 13 times 5 is 65. You will always have a common denominator. All right? Because they have the same hypotenuse. Negative 48 plus 15 is negative 33 over 65. That's what you end up with. Good. All right. The last one, cosine of u plus v, given sine u is 12 over 13. U is between 0 and pi over 2. Cosine v equals negative 3 over 5. If the sine u is 12 over 13, the Pythagorean triples tell us the cosine u would be 5 over 13. If cosine v is negative 3 over 5, then the sine of v would be 4/5 if it's in pi over 2 and pi. And then we use the formula cosine of u plus v equals cosine u cosine v minus sine u sine v. Cosine of u we derived was 5 over 13. The cosine of v given to us was negative 3 over 5. The sine of u given to us was 12 over 13. The sine of v we derived was 4/5. 5 times negative 3 is negative 15. 12 times 4 is 48. Negative 15 minus 48 is negative 63. So we end up with negative 63 over 65 for our final. We got it? All right. Here we go. There. Try not to poke you in the head this time. I'll just put it on your your desk. I apologize for assaulting. All right. There we go. All right, so the 14 on the front. All right, you'll notice they're all pi over 12. The one thing I would go over with you, the only thing that's different is the possibility of negative. All right. So for example, if you look at number 7, all right, you look at number 7, it's negative 7 pi over 12. If we think of pi over as 180, that would become negative 105. All right. All I would do is think of two angles in our family of unit circle that subtract to 105. That'd be 135 and 30. And then switching to 30 and 135. So 30 minus 135 would be negative 105. So this would basically become the cosine of 30 minus 135. And then you just do the same thing you did with the formula. On the back, all right, they give you sine u is 5 over 13, cosine v is negative 3 over 5. And then in 47 through 50, the one thing I will tell you, remind you of, 7 and 25, the third number in that family is 23. So you're dealing with the 3, 4, 5, 5, 12, 13, 7, 24, 25 families. If you want to draw your graphs, fine. If not, all right, if you can derive, all right, the others. So in other words, when they give you sine u, you're expected to be able to figure out what cosine u is. When they give you cosine v, they expect you to be able to figure out where sine v is, and vice versa. So you use the one to get the other. All right. That is due tomorrow night at midnight. Tomorrow, we are doing the second part of this lesson, all right, which is working backwards, improving identities. So you want to pay attention to the live stream or the video for that. There'll be a homework that goes with that. That'll be due Thursday. And then Thursday, when you come back, we'll work with the third part of that, which I think is solving equations. And then that assignment will be due Friday night at midnight. All right. Oh, that would be me.
I still have 0 for that.
I don't care. What are you going to say, that I assaulted you? And you're now going to use that against me to say, oh, you just beat me up. I'm going to tell the local authorities that you beat me up with a piece of paper if you don't change the 0. Unbelievable how I'm being extorted. All right. Yes. Sounds very nice. So the solving trig equations too?
Yeah.
All right, so we're in 3A? Absolutely. Solving trig equations. All right, so it was due on, the 2nd, and you showed it to me on the 3rd.
Yeah, I should do that.
Yes, you did. So it's late, but not phenomenally late, just moderately late.
A little bit late.
Because I did assault you, I'll give you a half point extra. And that should quiet you. That should be the hush money you need. Yeah. All right. Up to date.
Thank you.
No, thank you for being patient with me. You're looking for extra help, Miss Adams will be in the math lab today.